YouTube channel, What, Why and How. See, today I will select one example of CBSE illustration 3.6. See here friends, this is a one cube which have the 12 register is there. This is the 12 register and the value of one register is a 2.2 plus or minus 5% ohms. But in given a data, the register value is a 1 ohms. In this example, we have to find out the equivalent resistance of a given this cube, and we have to find out the total current I. So see here friends, step number 1 of this example, step 1, what is given in the data? Epsilon is equal to 10 volt is given, which is given in the first line of the data. The resistor, internal resistance of the battery is a 1 ohms. And what we have to find out? We have to find out equivalent resistance of a given this cube. Second thing, we have to find out current I of a given this cube. See, you know very well friends, second step, the figure of a given this cube is here, or the diagrams, and the model of these diagrams is here, which have the 12 resistor is there for a given this cube. We know that friends, Kirchhoff first law for a closed circuit loop, I is equal to I1 plus I2, that you know very well. Kirchhoff second law is a Kirchhoff voltage loop, that also you know. So we have to use in this numerical two rules. Rules number 1, that is Kirchhoff first law. Rules number 2, Kirchhoff second law. You know very well. See the friends here. This is the input data of a given this cube. That is suppose 3I current. I have a 3 branch I. Total of that is a 3I. Because Kirchhoff first law. If you select 6I, then again branch is there 2I and 2I. Similarly at the point D, again 2 branch, that is I by 2. Similarly for the A dash, again I by 2. Similarly on the branch of that with respect to the junction point B, I by 2. You know very well friends, total current reach to the junction point C, that is the I, that is output in 3I. So it's a complete loop with respect to the current 3I. Now how to calculate these numericals? Let us see. In slide number 2 we can observe here how to calculate these friends. You know very well there is my third step, and that step is working as a for the before and after. My third step is there how to solve the problems. Step number 1, before. Before means first of the given this cube, and that is the A dash with respect to the D dash and C dash. This is the first step by using the Kirchhoff second law. We know very well is a minus IR minus I by 2R minus IR is equal to minus epsilon. If we simplify epsilon this side is equal to 0. More simplification, phi IR by 2 is equal to epsilon, equation number 1. Similarly, after that second part of this example, and that is the AC dash. Remember, there is a one resistor between these two. From a given this diagonal, one resistor is here. You can see in the figure R dash. So what is happened now? By using the Kirchhoff second law, this is the journey loop is given here. Journey of this. So it's a 3I, and the battery value is a smaller stick and long stick. My new idea is there by using Kirchhoff second law is a minus 3IR is equal to minus epsilon. Remember friends, is a small stick of this battery, and journey touch arrow here working as a right hand side minus epsilon. This is new idea to select the epsilon value. So we can get the equation to 3IR equivalent is equal to epsilon. By using this equation 2 and equation 1, we can get to the more simplification. 3IR equivalent equal 5R by 2. More simplified, you are getting R equivalent is equal to 5 by 6 ohms. But we have to find out also current. So we were in very well about the Ohm's law. I is equal to V into R. That is the voltage transfer in epsilon into R equivalent. So what we are getting here, that is I is equal to 10 into 6 upon 5 into 3. So I is equal to 4 ampere. So our answer of today's example, R equivalent to 5 by 6 ohms and I is equal to 4 ampere. This method you know very well. Now let us see that which I have find out and done the research for this example, and my new technique is there, short method solution. SMS of this example is there. You can see in this figure of a given this cube. What is happen, friends? Give the number for the 1, 2, 3, 4, similarly 5, 6, 7, 8. Now see here from the junction point 1, 3 branches, 1 to the 2, 1 to the 5, 1 to the 6. The value is R. Is a R by 3 due to the parallel. Similarly, about the 7 junction point, R by 3. Let us see how to calculate this. Suppose the junction point 1 I will put in here. Again, second junction point 1 connected to the 2. So I will write 2. 1 connected to the 5. I will write 5 here. Again, 1 connected to the 4. I will write 4 here. So, how to connect these things? How much a resistor is given? Remember, friends, there is a 3 resistor. 1 to the 2 is a 1 resistor. Again, 1 to the 5 is a second resistor in this circuit. Again, 1 to the 4 is a third resistor. It's a parallel connection. You know very well, friends, is a R by 3. Similarly, the last point about the junction point 7 number. You know very well junction point 7 number. And the again a 3 resistor is there. Similarly, whatever I have done just now, 1, again 2, again a 3. So what is happen, friends? Is a again R by 3. Because 7 related to the 6, 7 related to the 3, 7 related to the 8. So which junction point is that? It's a 6 number here. Again 7 to the 3 number. Again 7 to the 8 number. These three are connected to the given second junction point for a given this value. So what you can observe here again, friends, 6 resistor is there. Out of this 3 and 3, 6 resistor is left. So number 1, this is the number 2, this is the number 3, this is number 4, this is the number 5, and this is number 6. So what we can write, friends, is R by 6. Very simple. Now we have to take the LCM of this. So R equivalent is equal to, we can write here, is a R by 3 plus R by 6 plus R by 3. So what we are getting, R equivalent is equal to the value of, that is the given resistor 5 upon 6 R ohms. Remember, friends, this is one of the very good short technique, that is SMS of the physics which I have developed, which is helpful to NEET examination of all India level, which is helpful to the JEE advanced. Very small interval type you can calculate directly. So this is a very good technique I have developed. Please, friends, if you like this video, share to your friends. Okay, thank you very much.